All right, open that notebook. Let's do some we do. So for starters, it's going to be tough to draw these. So in your notebook, drawing 3D figures is a nice thing to know how to do, though. Here's how I do it, if it helps. I would draw the front, so a rectangle like this, and then I would draw the back. You'll notice the corner is very close. The bottom left corner is close to the top right corner of the front one. So then draw the back, and then you'll have two rectangles on your paper. And then you can just connect top left to top left, top right to top right, bottom right to bottom right, bottom left to bottom left. So if you need to pause now and practice drawing that a couple times, go ahead. I think that's the easiest thing. Draw this, then draw this, then just connect, and it looks pretty good. All right, so for starters, the typical formula you already knew when we started doing volume in 5th and 6th grade was volume of a rectangular prism. That only works for a rectangular prism with length times width times height. If you want to write rectangle only, that is probably a good idea. So when you learned that formula in 5th and 6th grade, you would have just looked at this and said, the length is 7, and the width is 3. Again, it doesn't matter which is which. And that's 11. And that would be 21. Let's do 7 times 33. Okay, to 2, 21. So like 231, something like that. 231 cubic inches. So that's the old formula. So I want you to start getting used to using the new formula, which is this. We kind of combined those. Length times width, if you do that, we're going to call that big base. That's area of the base. Length times width is the formula for area of a rectangle. And so if you do length times width, that's going to give you the area of this, if you want to refer to that. So the area of the base, then times the height. I want that to be your new volume formula, area of the base times height. And the reason I care about that is that this formula only works for rectangular prisms, only. This formula works for any prism, so anything that has two like bases and rectangle sides. So in that case, this one, the area of the base, 7 times 11, that's going to give you the area of the base. The area of the base is 77, then times 3 for the height. And that'll give you the volume, which is still going to be 231 cubic inches. So that's that. I want you to really get used to this formula, which is used more because, again, it works for others. So after you have written that down and understand that one, rewind if you need to. Let's do a triangular one, and we'll talk about that too. So this one, if you want to get used to drawing, they didn't draw the back, so if you want to draw in the back, that may help you get used to drawing it a bit easier. Yeah, no, that kind of made it worse, didn't it? Let's not do that. So take a shot at this. So to draw this one, it looks like you would draw a triangle first, and then extend back from the top, extend back from the bottom, and close it off. Do it lightly in pencil till you've got one that looks good. And then you can unpause and we'll work it out. So this is a triangular prism, which means what's tricky here is when we find the area of the base is a triangle on a triangular prism. So when we say base, we're not necessarily talking about the side that it's sitting on. We're talking about what its base is by its name. So there's a triangle front and there's another triangle in the back. That makes it a triangular prism. Then the sides, rectangle, the bottom would be a rectangle, and this back side here would be a rectangle. So it's a triangular prism, and its base is a triangle. So we're going to use this formula, where big B times H, where if you want to note, the big B is the area of the base. So this one takes a little more work because the area of the base has a more complex formula than you're used to seeing. So here, the area of the base is the area of the triangle. And triangles, the area of a triangle is the base times the height divided by 2. So in that case, that is 10 times 8 divided by 2, that's 80 divided by 2, that's 40. So that triangle has an area of 40 times the height, which again, the height is weird when the prism's not sitting on its base. It's not sitting on the triangle. If you kind of turned this and it was sitting on its base, the height would be that. But it's kind of strange to call it the height when it's sitting this way. But the height's this other dimension. So we look and say, okay, it's 10 this way, and its height would be this 6 equals 240 cubic centimeters. So area of the base times the height. So pause here. When you're done with that and you understand that one, again, rewind if you need to for a better explanation. We'll do one more example. This is a cylinder. It is not technically a prism, if you want to make that note, because the sides are not rectangles. On a prism, all the sides other than the base are rectangles. Here, a cylinder just has this one kind of curved side, but the same formula still works as a prism. So that's nice. So this is called a cylinder. Its bases are circles. So when we use that formula, volume equals the big base times the height. The base is going to be the area of the circle, top and bottom, which is pi times the radius of the circle squared. That's our formula to find the area of a circle. The way this is oriented, it looks like an oval. So the radius here, if the diameter is 10, the radius would be 5, so I need pi times 5 squared. 5 times 5 times pi. It's 78.5. That's the area of the base. That circle has an area of 78.5 square inches, then times the height. And this one, it is sitting on its base, so the height is actually the height, which is cool, times 6. 471 cubic inches, which means if I filled it with 1-inch cubes, I would be able to fit 471 in there. That, my friends, is how you find the volume of cylinders and prisms using this new fancy formula. How do I know if I learned this? Some things I would want to know is, first of all, can you tell me what a prism is? So remember a prism, well, I'm going to ask you if you need to go back and watch this. Can you tell what a prism is? Second thing, can you apply the volume equals big base times height formula? And last but not least, do you know where this comes from? I explained the old volume formula and the new volume formula. Do you know how it comes from? And can you apply it? Then you're all good. This was a lot in one lesson, so anything you need to go back and see again, if it wasn't clear, please do. Geometry, I find, often is the hardest branch of math for folks and can take the longest to sink in. So if you need to double check this, please do. And after you have, I will see you tomorrow.